Here we go. We are going to be looking at percentages and ratios today. Let's start it off. I'm going to want to increase the number 30 by 20%. Well, that's just a simple matter of taking 30 times this as a decimal, which is really 1 plus 0.2. That will give me my answer. Now let me explain this. This 1, these are both decimals, yes, but they're actually standing in for percentages. This 1 stands in for 100%, and this 0.2 stands in for 20%. Now, the 100% is in there because if I don't have it in there and I just multiply 30 times 0.2, that will only give me 20% of 30, which is not what I want. I want to get my original 30 plus 20%. If I wanted to, I suppose I could do 30 times 0.2. I'd get that. I'd find out that my answer would be 6, and then I could add that on to 30. However, generally, I think you will find that it's easier to work with these two together, or 30 times 1.2, which gives you 36. It's all done really kind of in one motion, because this 1.2 is standing for 120%. If you have all of something, you have 100% of it. If you have all of it plus another 20%, that's 100%. 120% is just equal to your 100% plus 20%. Okay, great. So 36 is 30 plus 20% of 30. So it would make sense then that if I wanted to decrease 36 by 20% of it, I could say, oh, well, I'm just going to work on the fact that I know that I just increased by 20%. So 36 minus 20% would just give me 30. And if you thought that, then I'm sorry, but you would be wrong. That's not actually how it works. It is weird. Why is it weird? Well, let's take a look at this as a fraction. What this really is this 1.2 we can think of in terms of 30 times 120, that's the percentage that we talked about a little bit earlier, over 100. The word percent literally is per 100. If we look at the Latin roots of the word, that the cent is like century, centennial, that's a root of 100. That's why our pennies are called cents, because you need to have 100 to have a dollar. If you have 30 times 120 over 100, that's going to give you the same thing as 36. 120 over 100 is 1.2. Percentages also function really well as ratios. So let's look again at where we were a moment ago. If I want to get 36 equal to something that is 20% less, I cannot just assume and work from what I had a moment ago, because watch this. If I do 36 times, well, 20% less than 100% is 100 minus 20, which is 80. So I have 80%, 80 over 100. And that gives me 28.8. My 20% is actually a lot larger than 20% of 30 because this is a larger number. 20% of a larger number is going to be greater than 20% of a smaller number. 20% of 36 is going to be greater than 20% of 30. It makes sense. So they are not the same. And here's a little bit more as to why. if we go back to our original equation there of 30 times 120 over 100 equals 36, we can work this backwards and solve it, treat it basically as an algebraic equation, which, hey, would be a swell idea, wouldn't it? To balance this out, I can multiply 100 on both sides. I'm left, those would cancel there, so I'm left with 30 times 120 is equal to 36 times 100. Let's clear out the 120 on the left, and then I get those cancel. 30 is equal to, I'm going to phrase this a little bit specifically over here, 100 over 120. It's a ratio. Remember, ratios are just dividing, so we can treat them just like we're dividing numbers because that works, that makes sense. Let's do that. It's comfortable, it's cozy, it's great. But here's our ratio. Here's our actual percentage of what 30 is of 36. It's 100 over 120, which if we look into our calculator, this is actually 0.83 repeating. This is, let's put it in red, not 80%, which is that 20% less than 100 we thought of. So we cannot just say that 20% more than 30 or 20% more of any number is the same as 20% less of that larger number. It is not a blanket statement that we can say. It just doesn't really work. So keep that in mind, and if you think about decimals and ratios and how they relate to each other, particularly with percentages, we'll see some neat connections. Actually, what we have down here, there's our thing we just discovered, the 120 over 100 and the 100 over 120, which we had here and here, they're reciprocals of each other, and that they're not going to be equal to each other. 120 over 100 is 1.2. 100 over 120 we said was just 0.83 repeating. So please don't make the mistake of thinking that we can keep applying percentages and they're all going to be kind of taking care of themselves. Think of them as ratios, and you can set them up as such. It makes things a little bit easier. And let us do one more quick thing here. Remember, if we want to find out what percentage of a number, in this case 30 is what percentage of 36, we can just divide, and then we would see that that 30 is, there's our 0.83 repeating, or 83.3 repeating percent of 36. Or vice versa, you can do 36 over 30, and then we get 1.2, which is 120%. Alright, we will continue to work with our ratios and percentages. Think about this, ponder it, let that absorb and create synapses within your brain, and have a great day while you're at it.